Hi, and welcome to Pizza Clicker Lesson 5. Today we're going to look at making this number better. Right now, if I have an insane amount of slices, this number gets difficult to read. So we're going to make that better. I could make all of this code here on the slice, but I want to be able to reuse this code. So I'm going to make a new sprite for that, just like we had the calculator. Doesn't matter which sprite we choose, we're not going to show it on screen, but I'm going to choose number 0 here, and I'm going to call it pretty numbers. And what I want to do is I want to take this number and I want to make it beautiful. So I'm going to take when I receive start. We have that on our backdrop when we start the game after every variable has been set. I will read the number from slices, and I'll make a new variable called pretty slices that I want to save it into. So let's make a variable pretty slices. It's for all sprites. And what I'm going to do right now, I'm just going to set pretty slices to, and what did we do here on slices? We set floor of slices. So let's do the same thing. See, floor of slices. Let's see what happens when I start the game. Pretty slices is set to 10 million. If I get more slices, pretty slices does not update. That's because we do not have this in a forever loop. So let's put this in a forever loop as well. And now if I buy slices, this number up here updates as well. Now we're going to go to my slices, my slice sprite. I'm going to say here where I say floor of slices, I'm just going to change that to use pretty slices here and here, and delete these two. So now when I run the game, it uses this number to display here. So now I'm ready to update this code to make more sense. I want to change my number so that if it's less than 10,000, I should just show the number. And if it's greater than 10,000, then I want to show 10K instead. So the first thing I would like to test, is this number bigger than 10,000? So let's say, let's invert that and say, if my slices is less than 10,000, then I just want to do this. So if slices is less than 10,000, I just want to do this. If it's bigger than 10,000, I want to divide it by 1,000. So let's set slices to slices divided by 1,000. Like that. Let's see what happens when I run the code. 0. Why is it 0? Into my forever loop here, I say if it's smaller than 10,000, do this. It's not smaller than 10,000, so it's going to divide by 1,000, and then it's going to do it again and again and again because it's inside a forever loop. So I don't want to change slices itself. I want to do this in a different variable. So I want to make a new variable. I'm going to call it number in for this sprite only. And before I do anything, I'm just going to set number in to slices, because now if I change number in down here, I don't change the number of slices the game thinks I have, I just change a copy of that number, which will not break the entire game. So let's see, this will be number in. I will set that to slices divided by 1000. And let's just use this new variable we created right here as well. And here. So we start by creating a local copy just for this sprite of our slices, and then when I start changing that number, it doesn't affect anything else in the game. Let's move this one down a little bit and this one down a little bit so we can see what happens. And now it shows 0. Obviously this down here should be pretty slices is slices divided by 1000. So now it will show 10,000 here. That is 10,000 thousands. Let's see what happens if I change it to 9999. What's going on? It says 9, 0, 999. The 0 is because we have a dot here in our pretty slices, and we do not have a dot sprite. We'll fix that later. But why does it not just show 9,999? It says if number is less than 10,000, then just set pretty slices to this number. And then it will also do this. What I want to use is I want to use my gatekeeper pattern. I want to say stop this sprite right here, this script. It will stop this script, so it will not get down here. Unfortunately, this stop will stop the forever loop, and I do not want that to happen. So I need to move this over to a new block. I will make a block and I will call it, let's see, reduce number. And I want to run it without screen refresh. This is not going to update any sprites on the screen. Here. And I will say reduce number here. So now if I start, it will show 9,999. And when I click the pizza, it will show 10. This is 10,000. And now it will show 10.001. I can see that I'm showing this sprite here on the screen. So let's hide that. This makes it look better. Let's see what happens if I write a slightly bigger number of slices here. So let's start with 99,999. I had to restart again to show the issue here. It's 99.999, and we're still missing the K. We'll fix that later. And the dot is a pizza slice right now. But I do not want 3 digits after the decimal point. In my version, I want only 2. So we're going to have to look at these pretty numbers here again. The first thing I want to do is I just want to show the number of thousands I have. So I can duplicate this line of code. It will just, my pretty slices is my slices divided by 1000. And if I take the floor of that, I will get my number of how many thousands I have. I'm starting to get a little bit confused about this pretty slices here. I'm modifying it many times. So I think I will create a new variable for this sprite only, and I'm going to call it number out. And everywhere I do something with pretty slices here, I'm going to do it with number out instead. Like this. And then after I'm done running this entire block of code, I will set pretty slices to my number out. So I have my number in is my number of slices. Then I do many things with number in and number out. And then I set my pretty slices to number out. I can see I forgot one here. This one should be number in as well. So now if I run the code, I don't need that one. Now it just says 99. It's 100,000. This is 99,000. That is how many thousands I have. Now I want to manually add this dot. We're going to need the dot. So I'm going to set number out, and I'm going to use this join operator. What I can do is it just takes two different strings or numbers and just mushes them together to one big thing. So I'm just say take whatever is in number out, add this to the end of it, and save it in number out. And the thing I want to add at the end is just a dot. Now if I run the code, it will say 99 dot. I think the next thing we should do is fix this dot. I'm back at my slice sprite. I go to costumes and I'm going to add a new costume. I do not want to draw anything myself, so I have a little bit of cheat here. I'm going to choose the 0 again. You can choose any sprite you want. I'm going to do it like this. We have to wait for the sprite to load. There it is. I'm going to choose the center, the white center here, and I'm going to delete that. And I'm going to choose the other one, and I'm going to make it smaller. And it's important to me that I make it smaller down. This is where the sprite is anchored, and I want to make it align with the floor of all the other letters. So if I just make it down, then it's still going to be aligned. Now when I start to move it, after I start moving it, I can press Shift, and now it will only move diagonally and up and down. So I can just move it to the right, and I want to place it right under the anchor up here. You see the anchor is between these 4 squares, so I can follow this line down, and that should hit the top of my dot here. So now if I run the code again, oh, I need to rename the costume to a dot, a period. And now if I run the code, it's going to have a dot right here. I think I'm going to make the numbers, have them a little bit closer together so it doesn't look so weird. So I changed this distance between the numbers from 30 to 25. Let's talk a little bit about how I'm going to find the digits after the dot. So my original number is going to look like this now because I divided it by 1,000. So it's 99,000. It's 99.999. And so far my output number is 99, and I added a dot as well. Let's count the digits up here. There's 1, or the characters, 1, 2, 3, 4, 5, 6, and down here I have 1, 2, 3. Now I want to get this number right here. And I cannot just say I want number 4, because maybe in the future there would be more thousands. So now this would be number 5, because it would be 1, 2, 3, 4, 5. So that doesn't work. I need to be able to somehow in code figure out what number is this. But I do have that I'm on number 3 right here. So I can say whatever the length of my current number out is, currently it's 3. I can add 1 to that. So that would be 4. And I want to get that number in my in up here. This is my out down here. So the length of my current out, which is 3, I'm going to add the 1 to that, and I want to get that number in my in. It will look like this in our code. So I'm going to set number out. I want to join the current number out, and then I wanted to join it with the letter, the first digit, the next digit from number in. So let's see, we're going to have to get the length of number out, which was 3 in our example. Length of number out. I want to add 1 to that. So here, plus, I'm going to take this, put it on the left side, and add 1 here. And I want to find that number in my number in. And we have that right here. I can take a specific letter number from somewhere. So I want to take, this is 4. I want to take letter number 4 from my number in. And I want to join that to the thing I had up here. So I'm going to take this and draw here. So you have to be careful now. There are 4 green blocks inside each other. If you put them in the wrong order, it's not going to work. I'm going to put that here. And now we'll say 99.9. And if I add 1 here, it's difficult to see it work. So let's just duplicate this line of code. If I go back to my paint here, if I want the next number, let's paint that in pink. No, let's go green. I added this now. Here. Now I want the next. I want number 5. I can do the same thing again. I can say, currently this is, my out is 4 long. I'm going to add 1 to that, which is 5, and I'm going to find that up here. So I can get this one and right here. But that is exactly the same code again. So I can just duplicate that line of code. And now it will show 2 digits after the dot. And if I start adding here, it does not work. What is wrong? I noticed here that I made a small mistake. This should be set number in. And this should be number in as well, in order to make my other explanation here make any sense. So as you see, I changed the number now. I changed it to 1, 2, 3, 4, 5, 6, so I can see are my digits being shown correct up here. For the number to show the way I want it to show up here, I need a space, and then I want a K. So let's just add that down here at the end. So I'm going to set number out to join number out with a space. There is a space in here. It's difficult to see. It's not empty. And then I'm going to duplicate this, and I'm going to add a K here. And as you can see up here now, I have 2 slices again, because these 2 characters, the space and the K, do not exist on the slice. So let's go to the slice and add the costumes. First thing I'm going to do is I'm going to add a random costume. Let's get an apple. There it is. And I'm just going to select it and delete it. And I'm going to rename this costume to space. There has to be a space here. It has to match the character in our pretty number string. So now if I run, this is a space now. Now we need to add the K. So I'm going to do the same thing. Choose a costume. Scroll down to the K. It's here. And wait for it to load. There we go. And rename that to a K, capital K. And now the number shows the way I want it to. 123.45 thousand. As you can see here, if I change my number of slices to 10,000, it's going to show 10.nothing K. Let's have a look at our beautiful painting here again. If this was 10,000 instead, so let's write 10,000. And I divide it by 1,000, so now I have 10.000. And down here I got the 10, and I got the dot, and now let's count. 1, 2, 3. 1, 2, but all of these do not exist because this is a number. This is 10 exactly. The way Scratch takes this number is it just makes it a 10 without anything after here. So when I'm trying to get character number 4 from up here, because 1, 2, 3, plus the 1. So I wanted to get this one, but it does not exist. We need to handle that case. So we go back to our code, and down here where we get the next character, we need to say, does it exist? So let's say, get an if-else block. I'm going to say, if the length of, where is it? Here we go. We need 2 of these. We need to compare the length of number out and number in. So I can only do this if this number is longer than this number. If it is shorter, if there's only 2 here and 3 here, then I need to manually write a 0 here. I cannot get it from up here. It does not exist. So I'm going to say, if my number out is smaller than number in, then I'm allowed to do what we just talked about. So let's grab one of these over here, like that. If that is not the case, then I add a 0 manually. So we're going to set number out to, let's grab this one, to number out and a 0. And I said we don't normally use if else. The key word is normally. Sometimes it's okay. I'm going to put this one here. I'm going to put this here. And this one back. So now I got a 0 here, just like I wanted. I want 2 of them. I do not want to copy this entire block again. Even sometimes some of you might want to have 3 digits after the dot. So what do we do if we want to run the same code multiple times? We use the repeat block. So I'm going to put it here. I don't want these 2 in here. I'm going to repeat that 2 times. So now it's 10.00 and delete that one. Now that's all very good. But if I have a bigger number, 10 million, it's going to say 10,000 K, 10,000 thousands. I would like that to say 10 million instead. So we need to modify this code. We could say, if number is smaller than a million, do all of this. And then we could add a new code block under that says, if number is smaller than 1 billion, then do something else. And smaller than 1 trillion, do something else. But there's really no upper limit to how many times we would have to repeat that code. So let's be a little bit clever about this. First of all, we need to decide how many times do I need to divide by 1,000. So let's keep a track of that, and let's make a variable that says multiplier. That is, how many times have I divided by 1,000 for this sprite only. And let's set that to 0 before we start reducing anything. I'm going to take all of this and move down here. And I'm going to say, this divide by 1,000. I want to do that until my number in is smaller than 1,000. If I go here and I write a random number down here, 1, 3, 5, this is very beautiful, 8, 0, 4, 2, 1, 3, 8. I think that's enough. So now we divide by 1,000. Is this? And we say, is it less than 1,000 now? No, it's not. Okay, let's do it again. We remove this. Is it less than 1,000 now? No, it's not. Okay, so let's remove this. Is it less than 1,000? Yes, it is. So it's 13 something. Thousands, millions. So it's 13 billion. But we don't care about billion right now. We just care it is 13 of something. So what we want to do is we want this repeat until. And now the code is going to lag out because this block here is just going to run forever. If I try to move something now, it's completely laggy. So because the code is running, so let's stop the code. I'm going to say I'm going to repeat this until my number in is smaller than 1,000. So it does it first, and it says, now is it smaller than 1,000? No, so do it again. And I want to add 1 to my multiplier because I wanted to remember how many times have I done this. So I'm just going to change multiply by 1. And now I can add this again here. Obviously, this is not correct because it's not 10,000, it's 10 million. So this was just the first step. The next step is to decide what should I write down here. For now, I'm just going to move these 2 blocks out here, and we'll talk about how to do this in the next class. See you next week.